Good morning, student. Once again, welcome back to the session number 5. So, in that, once again, we are continuing with the design and problem session on the screw threads. So, let us begin with the content of this session. So, in the last class, we have discussed about some of the examples based on the tensile stress induced in the screw fasteners. So, that is the some of the problems which are based on the tensile test. Most of the problems we are covered. So let us begin in the today's session. So some other different types of problems, that is design. So here in this session the content is like this. Some of the examples are we are solving, and question answer session is there. Some assigning homework problems and multiple choice questions, and finally some of the references we are indicating. So let us begin with another type of problems. So let us take down this. So the problem is like this. The problem 1, that is find the diameter of the screwed boiler stays. Each stay supports an area equal to 200 mm by 150 mm. The steam pressure is 1 Newton per mm square. The permissible tensile stress for stay material is 34 megapascal. So this is the problem he has given. So first of all, here we have to extract the given data. Once again we can read out the problem. So he has asked, that is, find the diameter of the screwed boiler stay. Each stay supports an area equal to 200 by 150 mm. So the area of the stay is, he has given, that is 200 mm by 150 mm, and the steam pressure he has given, that is pressure PR, which is equal to 1 Newton per mm square, and the permissible tensile stress for the stay material considered as 34 megapascal. So these are the given data, that is area of the boiler stay, that is A is equal to 200 by 150 mm. So you just simply multiply it and you are getting nearly, that is 30,000 mm square. So this is the area of the boiler stage, and the steam pressure 1 Newton per mm square, and the permissible tensile stress is induced in the boiler stage, that is 34 Newton per mm square. So here then we are proceeding. Already we know that. So we have to here in this case we have to find out the tensile load acting on the boiler stage. So how we are going to find out? So already we have discussed in the previous session, that is, so the force or load which is equal to, that is area into pressure. So this is we are taking from the basic definition of the pressure. Pressure is nothing but force or load per unit cross sectional area, and we want the tensile load acting on the boiler stage. Therefore force or load which is equal to area into that pressure. Now you substitute the value here. Area is 30,000 mm square is there, pressure is 1 Newton per mm square is, and substitute the value 30,000 into 1. So you simply multiply it. So therefore force or gas load you are getting 30,000 Newton. So this is 30,000 Newton. You got the force or load is acting on the boiler stage. So now we have once you found the value of this force or load, already we know that when the bolts are subjected to the tensile loading, okay, so that is given by the equation. So you use that equation and we are going to solve the problem. So but we also know that screw threads are subjected to the tensile loading is given by, so this equation, that is P is equal to pi by 4 dc square into sigma t. So now here once again you substitute the value. P is given, already we found here in the previous case, that is 30,000, which is equal to pi by 4 dc square as it is, so and into, that is sigma t he has given 34. Substitute and simplify. Do it fast. So after simplification you are getting, just substitute the value, simple multiplication and division is there. So after simplification you are getting 1123 mm square. So but we want the value of DC. So just you take out the square root of that. So you are getting, so you calculate here along with VU. So I will also calculate. So here, that's the square root of, what is the value, 1123. So nearly, so that is the root or core dia. So that is DC is equal to, you are getting 33.5 mm. But this is not a final answer, but we want the nominal diameter of the bolt. So now assuming the chorus thread, so that is DC is equal to 0.84D, substitute the value and you find out the value of nominal diameter D. Therefore D is equal to DC divided by 0.84, and substituting the value here nearly you are getting, so that is 39.88 mm. Or from the design data book, that is table number 9.15, you can use that. So from that, the directly you can once again in the, that is the DC you have already found. So you open the design data book, that is the table number, so 9.15. So along with that, so you find out the value. So you look out the table. So in that you are getting, so that is M39 is the standard nominal diameter of the bolt. Yes, given. So like this you have to solve the problem. This is one of the just a little bit it is same as compared to the last session problems. So let us go ahead. Let us will move on to the another type of problem. Now you take down second problem. Find the diameter of screwed boiler stays. Each stay supports an area equal to 300 mm by 150 mm. The steam pressure is 1.3 Newton per mm square. The permissible tensile stress for stay material is 50 megapascal. So this is the, once again the same similar problem is there as we have solved in the previous, that is session, previous problem. It is similar to that only. So first of all you have to write down the given data. So he has find the diameter of a screw boiler stage. So you have to find out, no doubt, that is nominal diameter of the bolt. And here also he has given a stay which supports an area equal to 300 mm by 150 mm. That is the area of the boiler stay. So he has given by 300 mm into 150 mm. So you simplify it, 300 mm into 150 mm, multiply it. So we are getting 45,000. So nearly we are getting 45,000 mm square is the area. And the steam pressure he has given 1.3 Newton per mm square. And the permissible tensile stress sigma T he has given 50 megapascal. Just to convert in the Newton per mm square, that is 50 Newton per mm square. Once again we are proceeding in the same manner. So already we know that from the basic definition of the pressure is nothing but force or gas load per unit cross sectional area. So that is known as the pressure. So from that our requirement is to find out the tensile load or force, that is gas load, is acting on the boiler stay. So therefore force or load acting on the boiler stay, that is which is equal to, that is cross sectional area into the pressure. So this is pressure. Now you substitute the value. Put the value, area is 45,000 mm square and the pressure is 1.3 Newton per mm square. Now you substitute the value here and you just simplify it. So 45,000 into 1.3. So here, so you simplify it, nearly you are getting 58,000, that is 500, that is that much amount of the load is acting, that is 58,500 Newton load is acting on the boiler stay. So let's go ahead. So but we also know that Then the bolts are subjected to, that is, tensile loading, which is given by the equation, that is P is equal to pi by 4 dc square into sigma. Now you substitute the value here. Already we have found the value of tensile load, that is 58,500, which is equal to pi by 4 dc square. We have to find out the dc square into sigma t. Sigma t is already given. Substitute the value and simplify it for dc square. So if you are simplifying for the dc square, you are getting dc square is equal to 4 into p divided by 4 into p divided by pi into sigma t. Put the value and find out the value. So therefore nearly you are getting 1489.5 mm square. So this is the value of dc square, but we want the dc. So take the square root of this, square root of this, so that is 1489.5. so here, so square root of that you are getting 38.59. so this is the value, root or core diameter, that is 38.6 mm. And proceed further, we have to find out the nominal diameter of the bolt. So assuming the chorus thread, this is equal to 0.84 d. So therefore from that t is equal to, that is dc divided by 0.84. Put the value, that is 38.6 divided by 0.84. So here you are getting, that is 45.95 mm. This is the nominal diameter of the bolt, or you can use the refer the design data book, or you can also refer the design data book. From machine design data book, the table standard size is limited to up to the, that is M39. So for the bolt series, so in the design data book, that is the standard sizes for the bolt, so it has limited to the 39 M39. so therefore we have to use the whatever the equation, that dc is equal to 0.84 d we have used, and we have found the value, that is we are getting the M46. Otherwise you can also refer the for the metric series. So in the metric series also we are getting, so for the core diameter of, so that is core diameter, so that is for the 38.6. For the 38.6 you look for the, that is metric thread is there, 38.6. So 38.6, that is minor diameter. So that is for that also you are nearly getting the same value. So you can round it to that. So design data book you can. So since we are using the, that is the chorus series for the bolts, so for that we have kept the value same, that is M46. So if you have any questions you can ask. Otherwise, so we will proceed further. The next type of problem we are going to solve here. Next you take down another one. Take down. Two shafts are connected by means of a flange coupling to transmit torque of 25 Newton meter. The flanges of the coupling are fastened by 4 bolts of same material at a radius of 30 mm. Find the size of the bolt if the allowable shear stress for a bolt material is 30 megapascal. So this is a little bit the problem. Somehow whatever the problems we have solved so far, it is totally different from that. So already in the third session we have explained about the different types of, that is the basic definitions we have used, that is for the torque, pressure and all those things. So here also you have to use that. By the knowledge of that basic definition, we are going to solve this problem. Remaining methods are same. So but first of all you have to extract the data. Here he has given two shafts are connected by a flange coupling to transmit the torque. So that is, so far that is he has given the torque. The torque he has given 25 Newton meter. So 25 Newton meter he has given, but we want in Newton mm. So therefore the torque which is equal to 25 into 10 raised to 3 Newton per mm. So the value is 25 into 10 raised to 3 Newton mm. So already we know that 1 meter is nothing but it is a 1000 mm. 1000 is nothing but a 10 raised to 3. So from that we have converted, that is 25 into 10 raised to 3 Newton per mm, and fastened by 4 number of, that number of bolts are 4, n is equal to, small n is equal to 4, and the same material at a radius of 30 mm. So the 30 mm radius, and shear stress for the allowable shear stress for the bolt material, that is tau is equal to 30 megapascal, that is 30 Newton per mm square. So here already we have designed the bolt based on the tensile loading. So here the bolt we are designing based on the shear loading, that is shear stresses are inducing in the bolt. So from that we are going to find out the nominal diameter of the bolt for the coupling. So let us, so already here we know that the basic definition of the torque is what? Torque is nothing but it is the force or tensile load into, that is perpendicular distance or radius or diameter by 2. So from that definition, so we have to find out the force or load which is acting on the bolt. So here is from the basics of the strength of material only. So that is torque T is equal to force or load into radius or perpendicular distance, or we can write it as a diameter by 2. Diameter, half of the diameter is nothing but it is a radius. Half of the diameter is the radius. Half of the diameter is the radius. Half of the diameter is the radius. Therefore, T is equal to PS into PS or PS into, that is radius. So from that we have to find out the tensile load is acting on the bolt. Tensile load is acting on the bolt. So therefore we are using this equation, this PS is equal to torque divided by radius. Now you substitute the value. Now put the value. Already we have found 25 into 10 raised to 3. 25 into 10 raised to 3 divided by, it is acting at a radius of 30 mm. So put the value 25 into 10 raised to 3 divided by 30, you are getting 833.33 Newton. So this is this much amount of the 10, that is the shear load is acting on that bolt which are coupled, that is coupled to the coupling, that is mounted onto the coupling. So therefore already we know that when the bolts are designed based on the shear loading is given by, that is PS is equal to, so already we know that equation. So already we have discussed in the, that is third session, that is in the beginning of the problem session, that is PS is equal to pi by 4 dc square into tau into n. So now you put the value, substitute the value. Here already we have found the value of the shear load and the tau is known and number of bolts are already known, but you have to find out the dc square. Substituting the value, PS is equal to 833.33 Newton and pi by 4 dc square as it is, tau is already given and n is the number of volts. Just you rearrange the term for the dc square. Dc square is equal to 4 into PS divided by pi into tau into n. Put the value and find out the dc square. Just you check out it, how much value you are getting. Find out fast. So after substitution, so here we are getting, So 4 into 833.33 divided by 5 into 30 into 4, which nearly you are getting 8.84 mm square. So take the square root of this DC square. So we are getting the value of DC. Therefore, DC is equal to 2.97 mm. So, but this is not a final answer. Assuming the chorus thread DC is equal to 0.84D, substitute the value, that is, therefore the nominal diameter of the bolt, that is D, is equal to DC divided by 84. Put the value and substituting, that is 2.97 divided by 0.84. So here nearly you are getting 3.54 mm. Or you can also use from the design data book, the nominal diameter, that is, you open the 9.8, then ISO metric. In that, look out in the table. So for that you are getting for the two series, that is 3.5 mm is the standard dimensions of the nominal diameter of the bolt. So this is so like that we are going to find out that nominal diameter of the bolt. So if you have any doubt related to this, you can ask. So here the problems are very simple, but here tricky. There is no much more complications here. Only you are utilizing the basic definitions whatever we taught in the previous session. Based on that we are going to solve the problems. So pressure is the pressure, definition of the pressure thoroughly you should know, and the definition of the torque you should know. In further other design procedure also we are using the same thing. Okay. So next let us will move on to the another type of problem. So let us take down. The two plates are fastened by means of two bolts. The bolts are made of plain carbon steel 30C8 with yield shear stress in 200 Newton per mm square, and factor of safety is 5. Determine size of the bolt if PS is equal to 5 kN as given. So before solving this, once again you read out the problem. Two plates are fastened by means of two number of bolts. That is, number of bolts are involved in this. That is small n is equal to 2. And the bolts are made of plain carbon steel, that is 30C8. And here, that is yield shear stress he has given. You clearly read out. Yield shear stress is different. The allowable shear stress or the permissible shear stress is different. So here you write whatever he has given, that is yield shear stress, that is tau IT he has given 200 Newton per mm square. Okay. And the factor of safety he has given 5. Fs is equal to 5. And he has given PS, that is shear load is acting on the bolt material he has given directly. PS is equal to 5 kN, that is 5 into 10 raised to 3 Newton. So this is the shear load he has given. So before proceeding, so let us we should convert this for designing purpose. We want the allowable stress or the permissible stress induced in the bolt material we have to calculate. Already we know that from the basics of strength of material, to find out the allowable stress or the permissible shear stress or permissible stress, we know that the yield stress divided by the factor of safety, so that will give the permissible stress or allowable stress induced in the material. So you use that basic concept. So we have to find out first we have to find out the permissible shear stress induced in the bolt. So therefore the allowable or the permissible shear stress, which is equal to tau, is equal to yield shear stress divided by factor of safety. Substitute the value 200 divided by 5, you are getting 40 Newton per mm square. So this is 40 Newton per mm square. This is the actual shear stress which is acting on the bolt. So we have to use this value for the further calculation of the size of the bolt. Therefore, proceeding further, the nominal diameter of the bolt D we have to find out here. Therefore, we already know that the bolts are subjected to the shear loading. It is given by PS is equal to pi by 4 dc square into tau into n. Now here you substitute the value here. PS is already given, that is 5 into 10 raised to 3. Pi by 4 is already dc square we have to find out. Tau is we have calculated here and put the value of n. Substitute it. That is 5 into 10 raised to 3. That is 4 into 5 into 10 raised to 3 divided by pi into tau. Tau is 40 into n. N is number of bolts involved. So just multiplication and division is there. Just to do it fast. This is the value we are getting, 4 into 5 into 10 raised to 3 divided by pi into 40 into 2. Therefore, dc square you are getting 79.56. Now you have to, from this you find out the value of dc. dc is equal to, that is square root of the 79.56. Nearly you are getting, how much you are getting, you just do it calculation. Nearly you are getting 8.91 mm. So from this, that is assuming the chorus thread, dc is equal to 0.84 d, and therefore the nominal diameter of the bolt d is equal to dc divided by 0.84. Substitute the value. dc is equal to 8.91 divided by 0.84. So after simplification, nearly you are getting 10.61 mm. So this is the value of the nominal diameter of the bolt. Otherwise, you can open the from the design data book isometric thread. So in that you open the value, that is for the nominal diameter, the minor diameter 8.91. Look into the table 9.8. So in that 9.8. So in that the value is 8.91. For the 8.91, the standard metric ISO thread, here it is M10. So nearly it is same. Therefore, the nominal diameter of the bolt is M10 mm or M10. So you can use any one. Either you can but here for both the method we are both the method we are using. So any one method you can follow. If you are comfortable with the, that is porous thread equation, you can do that. Otherwise, you can also do the design data book. Okay. So here this is another simple problem. So whatever we have solved here. So if you have any doubt, let us you can just ask the question. So I think in this session, so these are the some of the very important the problems and design problems. Here we are covered almost the bolts are designed based on the shear loading. If you have doubt, we can. Otherwise, we will proceed further. So if you have any questions related to these problems, so now you can ask me. Otherwise, you can take down some of the homework problem we will assign for you of this. Take down homework problem. Number 1. Find the diameter of the screwed boiler. Stays. Each stay supports an area equal to 10,000 mm square. The steam pressure is 0.75 Newton per mm square. The permissible tensile stress for the stay material is 25 megapascal. 25 megapascal. You can solve here. The clue for this problem here, whatever the problem we have solved in this session, so the same problems are there. Instead of calculating the area, directly he has given the area, boiler stay area is given, steam pressure is given. So from that you will find out the force or the gas load is acting on the screwed boiler stay. So let us the remaining things are same. You can take down the second one. Two shafts are connected by means of flange coupling to transmit 35 Newton meter torque. The flanges of the coupling are fastened by 4 bolts of same material at a radius of 45 mm. Find the diameter of the bolt. If the allowable shear stress for the bolt material is 50 megapascal. So this is once again the same similar problem, only the values are changed here. So clue I will give. So clue for this problem, torque is given, you convert the Newton meter is there, convert in the Newton mm. N number of bolts he has given, small n is given, and the radius he has given, materials are placed at a radius of r, it is 45 mm he has given. Find the size of the bolt if the shear stress in the material of the bolt is 50 megapascal. Tau is given, just you do the calculation. Okay, it is very simple problems are there. Practice will make the more perfect in the designing. Okay, so let us move on to the that is assessment, that is the interaction or the MCQ session is there. So related to whatever the topics covered in this session. You can take down first one. Shear stresses are induced in a bolt when it is subjected to an external load is given by equation. So shear stresses are subjected to the induced bolt subjected to the external loading. At that time, following there are equations he has given, which is the correct for the shear load. So first one is the P is equal to pi by 4 dc square into sigma t into n. Second one is the d is equal to, that is square root of 4 ps divided by pi into n tau into n. And the third one is ps is equal to pi by 4 d square into tau into n. And d is the none of the above. Anybody tried? Which is the correct answer? Correct answer for this problem. So here the answer, correct answer for the this is ps is equal to pi by 4 d square into tau into n, option C, because this is the basic equation for the design. Okay, next let us take another one. Which of the following stress is not induced in a bolt when it is subjected to an external load? You read the problem. Which of the following stress is not induced in a bolt when it is subjected to external load? Option A, combined tension as well as shear. Second, shear stress is there, and C is the tensile stress, and the D is crushing stress. Try anyone. Okay. So already in at the beginning of that is the problem, that is design session, that is in the third session, we have discussed that what are the different types of the stresses which are acting on the bolts. So based on that we are going to design. So in that tensile stress is induced in the bolt, shear stress and combined stresses they are inducing in the bolt, we know. But there is another crushing stress he has given, that is option D. So the correct crushing stress is different. So yeah, we are not designing the bolt based on the crushing stress. Therefore option D is the correct. Let's take another third one. Load on the bolt calculated by, so we are calculating the load on the bolt is calculated by which equation following? A, P is equal to pi by 6 dc square into sigma t, P is equal to pi by 4 dc square into sigma t, P is equal to pi by 2 dc square into sigma t, and none of the above. Almost all we are using the more frequent equation here, which is the correct answer. So here from the basic definition of the stress, that is force into perpendicular, that is force into, that is force acting per unit cross sectional area. So that is known as a stress, or intensity of a internal resisting force or load acting. So therefore here P is equal to pi by 4 dc square into sigma t. This is the correct answer for the load on the bolt calculated by using this equation. And the last fourth one here, force or load into the distance is known as. So this is also another very important definitions we have studied in the previous sessions. Force into distance is what? So we have given option A is the power, option B is the pressure, option C is the torque, and none of the above. So here, that is, as per the question, force into the distance, that is force into perpendicular distance or radius or diameter by 2. So it is known as the torque. So here the correct answer for this question is the torque or twisting moment which is acting on the bone. So here the power is different. Power is, that is the, so the amount of that power produced by the system. So that is one. Pressure, definition of the pressure is different. The pressure is force per unit cross sectional area, and here the torque is nothing but load into the distance or force into perpendicular distance. Force into perpendicular distance is the torque or twisting moment. Therefore the correct answer for this question is option C. So if you have any doubt related to this, you can ask. So this is about the some of the multiple choice questions answers you have discussed in this session. So let us will move on to, these are the some of the references, whichever the references we have utilized in this session or in this the problem solving, we are also displayed here. So some of the references we have given. So some of the references here. So finally, so once again thank you for attending this session on behalf of our team, our Automobile team. So once again we say thank you for attending this wonderful session. So if you have any doubt, so let us, you can they are most welcome, we are most welcome for the questions. You can just put the mail, you can just put a mail, drop a mail, so we will at any time we can answer the question. So up to here I think I have covered so much topics, and I have covered a lot of problems in this session. So in the next session we will also cover some more problem. So here I think so in this session we will conclude this. So okay, once again thank you for the attending this session. Thank you.